Right, so welcome back to our YouTube channel. So in this video we want to go over momentum, but specifically we want to look at the conservation of linear momentum. So at this point I believe you understand what momentum is. Now momentum is defined as the product of mass and velocity. That's all, nothing else. So momentum is the product of mass and what? And velocity. Now, for us to understand the principle of conservation of linear momentum, here is the thing. So this was the total momentum of an isolated system remains constant if no external forces act upon it. Now, what does this mean? Let us say, suppose this is our body. Let us say body A, and this is our body. Let us call it body B. Now, this body A. Let's say it is going in this direction, and body B is also going in the opposite direction. Now this is before collision. Now for a body to, the word collision, two bodies are said to collide when they hit against each other. Now this is what is happening. So this is before, you can say before collision. Now what happens during collision is this body will keep on moving in that direction, and this one will also keep moving in that direction, implying that during collision, this is what will happen. We're going to have body A here. We're also going to have body B here. There's collision taking place here. Alright, so this is, we can say this is during during collision. Now after collision, where is this bus going to? In which direction will they move? Now here it doesn't matter the mass of these bodies, but what matters is the momentum. So the body will move in the direction of the body with greater momentum. So it doesn't matter the size of the body, or the mass rather, of that particular body, but what matters is the momentum. So bodies will move in the direction of the body with greater momentum. Now what happens after collision? So let us say after collision, perhaps we put it this way. After collision, maybe let us say the bodies, they all move in that direction. Right. Now the principle that you have to understand is the Newton laws of motion. For example, if we are to consider Newton's third law of motion, what does it state? So Newton tells us that for every action there is equal but opposite reaction. There is equal but opposite reaction. Now what does this tell us? This body here was going initially, was moving in this direction with its own what? Force. And this body B was moving in that direction with its own what? Force. Now Newton's third law says for every action there is equal and opposite what? Reaction. Now with that principle in mind, we also combine the principle of what? Conservation of what? Of linear momentum. Remember the principle of conservation of linear momentum. It states that the total momentum of an isolated system remains constant if no external forces act upon it, implying that the force, let's say force A plus force B, will remain constant. If no external forces act upon them. So force A and force B must give us what? Must be equal to what? 0. Alright? But again, from Newton's second law of motion, what do we know? We know that, we can say, but we know that from Newton's second law of motion, force is equal to what? Mass times what? Acceleration. Isn't it? Now we can combine these two concepts. Here we know that from Newton's third law, we are saying for every action, so we are going to have force of body A should be equal to what? The opposite reaction. In short, we are taking this force to the other side. So we are going to have the negative force of what? Of B. But from Newton's second law of motion, Newton's second law of motion is telling us that force is equal to mass times what? Acceleration. Implying that where there is force in this, we can substitute with what? With this. This implies that we are going to have mass of body A times what? Acceleration of body A. This should be equal to the negative, what is force again, you substitute with this, the negative mass of body B times acceleration of body B. Like that. Now, at this point, it is the point where we have to be very careful. We know that, what do we know about acceleration? So we know that acceleration, it is what? It is the rate of change of velocity. What does this entails us? This implies that acceleration is the change. We are saying acceleration is the rate of change of velocity, meaning it is the change of velocity with respect to time. This is what? Acceleration. Now, for a change in velocity, what does it implies? The change in velocity here, it implies the final velocity minus the initial velocity over what? Time. This is what the change here implies. Alright? Now, we can simply substitute this wherever we see acceleration in our equation. I guess this is very much visible. So, in this equation, we are going to substitute where there's acceleration. We are going to substitute with this. So we are going to have mass of body A times, what is acceleration? We are substituting with this. So we have final velocity minus initial velocity over time. Of course, this is for body A. For body A, and time we can say time for body A is equal to the negative mass of body B multiplying acceleration of body B. So multiplying VB minus initial velocity of B over time of what? B. Remember, the two bodies had collided at the same time. This implies that time of A is equal to what? Time of B. It is mathematically correct to cancel out the similar parameters. So if these two things are equal, we can simply cancel them out of our equation. This is mathematically correct. So what are we going to remain with? So we're going to say we're going to have mass of A multiplying velocity of A minus initial velocity of A. This is equal to the negative mass of B multiplying a final velocity of B minus initial velocity of what? Of B. We can simply expand, nothing else. And so in expanding this particular equation, we're going to have mass of A multiplying velocity of A. We're going to have mass of A, velocity of A, and mass of A multiplying the negative initial velocity of A. We're going to have the negative mass of A and the initial velocity of what? A. This is equal to this multiplying this. We're going to have minus mass of B and the final velocity of B, and negative times negative, it is positive. Mass of B initial velocity of what? Of B, like that. Alright, now here we can simply collect the like terms. So we can say, maybe we collect the okay, we can use anyway, whichever way is still fine. But in this case, maybe let us say we collect those with final velocity, we take them one side, and those with initial velocities, they be on the other side. So we're going to have mass of A, velocity of A. So this is going to come the other side with a positive sign. Mass of B, velocity of what? B. This is equal to, we take this one to the other side, we're going to have mass of A, which is now positive since it is negative here. We're going to have mass of A and the initial velocity of what? Of A plus mass of B and initial velocity of what? Of B. So we can swap this. We can bring this side, this thing to this side, and this can go the other side. There's nothing that has changed here. It is one and the same thing. So we're going to have mass of A. We're going to have mass of A times initial velocity of what? Of A plus mass of B times initial velocity of B is equal to mass of A times final velocity of A plus mass of B times final velocity of what? Of B. Now this equation, now it is the equation we are saying, the equation for the conservation of what? Of linear momentum. Now this implies that the product of mass of body A and the initial velocity of that body A, adding it to the mass, the product of the mass of body B and the initial velocity of body B should be equal to the mass of A and its the product of mass and the velocity of what? Body A plus the product of mass and velocity of what? Of body B. So this is how we mathematically express the principle of conservation of momentum, of linear momentum. So I guess this concept becomes easier for you. Remember to like, share, and if you are watching this video on YouTube, make sure you subscribe to our YouTube channel so you don't miss out. Thank you.